Hi, my name is Jay Solanki.
And my name is Ganpati Iyer.
So we have done our machine learning project using 20 newsgroups dataset. So we wanted to create an application which would be used for study purpose, and we could come up with good models that we could use for news classification. So we wanted to create various models using various algorithms, and we wanted to compare those algorithms and to find which one is better using the accuracy and precision measurements. And we also wanted to compare the clustering or algorithms versus the label documents. That is, if whether all the label documents of the same label fall under the same cluster or not. And then we wanted to use Alchemy API to classify the news, as Alchemy provides concept based news. Then the most important thing of this project was to classify live news. That is, the user can go to a screen and there would be live streaming of news using CNN API, and he would be able to see the news categorized. And then we have also one feature in which the user can put his own article or news, and you can see that in which categories it has been identified. So it would give a better sense of what the news is all about, and it can be also used as an API in future. So Ganpati will talk about the classification.
So basically, we have implemented two classification algorithms. The first one is naive Bayes, and the second one is support vector machines. For naive Bayes, we have implemented two approaches. The first one is word count, and second one is TF-IDF. So the basic method by which we implement this is by first having a count vectorizer and passing it to the model. Or if we are using TF-IDF, we pass the count vectorizer to the TF-IDF transformer and then pass it to the model. So after doing several experiments and tweaking of the parameters, we found that for smoothing factor 2 and approach TF-IDF with ngram 1, 1, we get the best results for naive Bayes. We have a precision of 73.5 and an accuracy of 66.6. So we can see here the confusion matrix that we have obtained for each attribute versus the other attributes. So if you want to have an ROC curve, so basically for a multi-class classifier, we need to plot an ROC curve, we need to choose an attribute, and the ROC curve would be plotted for that attribute versus other attributes. Here I have chosen the com graphics attribute, so ROC curve is chosen for that versus others. We can choose another attribute such as autos, and it will show the ROC curve for the same. We have implemented support vector machines too. So in this method also, we have all the same factors like the learning rate, the number of iterations, and approach, that is TF-IDF, word count, and the ngram. After experimenting for several values, we found that for learning rate of 0.0001 and number of iterations 5, with the approach of TF-IDF and ngram range 1, 3, we got the best results. Since the training of model takes a lot of time, we pickle the objects and show it in the database so that we can obtain the test results very quickly. So here is the precision and accuracy of SVM. We got a precision of 70.6 and an accuracy of 70.1. Here also we can see the confusion matrix of one attribute versus the rest of the attributes. So here we can choose a attribute for an ROC curve so that the ROC curve will be plotted for that attribute versus the rest of the attributes. I have chosen com graphics and the ROC curve is being plotted for the same. After doing all these experimentations, we were able to conclude that SVM with with the parameters that I mentioned before was the best algorithm in terms of classification. Now Jay Solanki will explain clustering algorithms.
So one of the objectives that I already mentioned was to find that the labeled news, if they are being clustered, whether they will fall into the same categories or not. And so we use k-means approach for that, in which we can configure the number of features interactively and make various models. So here for k-means and 10,000 number of features, we got the results. So we have, for performance characteristics, we have three things: the homogeneity score, in which in all clusters how many labeled documents fall together in the same cluster, and the completeness score is given a cluster and how many documents of the same label are present. and V measure score is nothing but their harmonic mean of these two. So we found that the completeness score of around 0.329 and homogeneity score of 0.234, which showed that around 30% of the documents are being of the same level are being clustered to the same category. So these are the actual clusters that were done by the k-means, and we can see that like cluster 5 is dominating, and others are having around like 1,000 documents in each. And so these are the actual clusters of the given labels, and we can see that they are between the 0 to 1,000 range. So this was, and we can change the number of features. So as we reduce the number of features, we can find that it adversely affects the results, and due to this, the all the performance measures falls. So earlier it was around 0.32, now it is around 0.11, and you can see that the clustering is more uneven as compared to the previous one. So this was one of, so in this we found that uh, the label documents actually don't fall into the same clusters. And the second algorithm that we followed were latent Dirichlet algorithm, in which it gives the best words or the best features of the given clusters. So as we are having like 20 clusters, it will give out all the important words for a given cluster. So as this algorithm, it takes all the documents and creates an image file of important words. It takes a lot of time, so I already have run this, and you can see that it categorizes all the words of the given cluster. For example, here Mac, card, Windows, etc. So it computer related stuff, and we have like education related stuff over here, and so on. So for example, in this we have HIV, cancer, so all the medical related terms together. So this helps us when we have like unlabeled data. It helps us to find all the important keywords for the documents. Now Ganpati will explain the Alchemy API test results.
So basically, our data set provides 20 categories, and it's very difficult to find data of that particular category. So we used Alchemy API as a Watson, and we passed the categories to it, and we got news articles related to that. Now we want to measure the performance of our algorithms with respect to this news articles. So suppose if we choose medicine, we want to see how well our algorithm performs. We see that for goals measured on obesity, food poisoning, we see SVM provides SVM predicts that it's related to medicine, and even Naviebase predicts that it is related to medicine. Similarly, we can choose other categories such as atheism and run it, and we will see that it gives pretty good results. Like in this skip church this Christmas, we see that SVM predicts this as Christian and Naviebase predicts this as Christian, but otherwise it predicts it as the next predicted topic is atheism. Now Jay will explain live news and classifying user news.
So as we said that the one of the most important part of this project was classifying live news, and giving an opportunity to the user to see an organized way of seeing all the categories. So we have all the tabs for each categories, and we can see that each categories are having some news, and so this news are real time. So some categories might not be having the news, but we can see that how it groups into the categories, and it labels them into these specific topics. For example, this news was labeled into politics misc, and so we have different categories like electronics. We have electronic related news over here, and you can see that we have used both the models to let the user know about what type of news he is watching. And so we have the final feature, that the classify news, in which we can basically enter a news and see about which category it belongs to. So here we have taken a mixed news, which might be atheism or science or related to Christianity, like God. There's mention of God there, and we see that the SVM model is able to find that it is atheism and also a little bit of Christianity. So we can not only see that which group it belongs to, but multiple groups which it might belong to. And you see, even Naive is doing it for Christianity and atheism. So now, Ganpati would like to conclude the video by saying few words.
So basically, after doing several experiments, we were able to conclude that clustering algorithms are not good for label data, as we are not able to find good results. And it should be used for unlabeled data to find intuitive results. And classification algorithms, we implemented multinomial naive Bayes and SVMs, and we were able to see from the results that SVM performs much better than multinomial naive Bayes. So for future, we are planning to implement more algorithms to more algorithms, clustering, and classification, so that we can compare it with the algorithms that we have already implemented. And if label data of other categories are also available, we would like to use that, so that we have got more broader categories in our training data set. Also, we will provide the user to provide to give us a feedback on whether the classification provided by the user for the user news is correct or not. In that way, we will be able to improve our model. With this, I'd like to conclude our demo. Thank you.
Thank you.